moving on to question 5 here. We have quite a tricky question, and it's to do with differential equations, right? So it's a differential equation modelling question in context. So it's nothing particularly exciting. It's about a diving board and measuring this using this differential equation. So like I said, pretty boring, but it's part of the question, so we've got to do it. So let's start right at the beginning. Part A just asks us to find a general solution of the differential equation for 2 marks, okay? So should hopefully be quite straightforward for 2 marks, so let's have a go at this. So part A. So to find a general solution for this, as this is a second order differential equation, I'm going to model this now using my auxiliary equation. So that's going to be 4m squared plus 4m plus 37. This is going to be equal to 0. So you can always tell if it's in this form where it's like a multiple of your second order, so your second differential plus 4 lots of the same differential here, and then plus 37 lots of like the function that you differentiated, then you can model it using an auxiliary equation like this. Now we need to solve this. So straight away this jumps out to me that it's not going to factorise, so I'm going to have to use the quadratic function, okay? So let's just do that underneath. So m is equal. So using my quadratic function, so you know this is GCSE, should hopefully be nice and easy. Minus 4 plus or minus. So it's going to be 16 minus 4 times by 4 times by 37. Okay. And this is all going to be over 2 lots of a, which is 4, so 2 times 4 giving me 8. So I'm just going to jump straight away to solving this. I won't show all the preliminary steps because it's nice and easy. This is going to give me minus 4 plus or minus the square root of minus 576. So we're going to have some complex roots here. Minus 576 over 8. And then simplifying that, that's going to give a half minus a half even plus or minus 3i. Okay. So we've got that here. That's my m. So now we just need to write the general solution. So, because in terms of h, therefore, h is equal. Remember, for this form now of a conjugate complex root like this, we write as h equals, so it's going to be e. So the first one, so minus a half t, times by a cos 3t. And plus b sine 3t. Okay, so that is my general solution for this one. So that's the first 2 marks there. Let's have a go at part B now. Okay, so part B, it's telling us that when t is equal to 0, so when t is equal to 0, the end of the diving board is 20 centimeters below E. So that's the position of the end of the diving board when it is at rest in its equilibrium position. So if t is equal to 0, what that's telling us is that h must be minus 20. Okay, so it's 20 centimeters below E. Okay, so minus 20. Well, if I know this, t is equal to 0 and h is equal to minus 20, all I've got to do now is use my general solution to obtain a value for A, and then using A we can then work out B as well. So what that's saying is that minus 20 is equal to e to the minus a half times 0, so that's going to be e to the 0, times a cos 0 plus b sine 0. Okay, well, this is still minus 20. That e to the 0 is just going to be 1, so it's going to be a cos 0, which is just going to be a, and that b is going to cancel, okay? So I get minus 20 is equal to a, or I can just say a is equal to minus 20, okay? So hopefully that's clear so far about how we've done that. We've just got a is equal to minus 20. So I've just subbed in t is equal to 0 and h is equal to minus 20, like we've been told just before part B here. Okay, so I can now get b, but to get b, I'm going to have to differentiate this, right? Because I'm never going to get a value here because my b is always going to cancel. And we've also been told that it's moving upwards with a speed of 55 centimeters, okay, per second. So if it's moving upwards with a speed we're talking about velocity, and we know the displacement here, that's h. So if I differentiate h, I've then got velocity, okay? So just going back to your basic mechanics, the derivative of velocity, displacement will give me velocity. So doing this now, so you will need a product rule for this. Obviously, I'm not going to show this as well because it's going to be quite long if I do, but I'll show you what you should get once you've done product rule, okay? Because you've got e to the minus a half t, and then you've got this bracket here. So split that up and then differentiate. So what you will get is minus a half e to the minus a half t. Again, you're going to get your a cos 3t, but we know a is minus 20, but we'll just keep it as is for now. A cos 3t plus b sine 3t plus e to the minus a half t again. And this time it's going to be minus 3a sine 3t. So sine 3t. So it's that long now I've actually gone off the paper. Oops, I shouldn't have closed the bracket just yet. Sine 3t plus 3b cos 3t. So 3b cos 3t. Okay, so this question is quite long and it's very easy to make a mistake, so I'm just going to try and take my time just so we don't make any mistakes here. So that's my differential now. That's my speed. So we can now use the fact that when t is equal to 0, okay, the differential here, so dh by dt, is equal to 55. That's what we've been told. The speed is equal to 55 meters per second, okay, or centimeters per second. So, using this now, I can work out that 55 is going to be equal, so minus a half e to the minus half t, so that's going to be 1 again, so minus a half, minus 20 times 1, so minus 20. So my first bit here, this b sine 3t will cancel, so I'm going to get minus a half, it's going to be minus a half of minus 20, okay? It's going to be minus a half of minus 20 here, because my a is minus 20 cos 3t, so it's going to be minus half of minus 20, right, so. And then I'm also going to get plus, so this again will be 1, this sine 3t will cancel, I'm going to get 3 lots of b cos 3t, okay? So that's going to be 3b over here, because cos 3t is just 1, so I get plus 3b. Simplifying this, I'm going to get 55 is equal to 10 plus 3b, so therefore 3b is going to be equal to 45, so therefore b is going to be equal to 15, right? 45 divided by 3, we get 15. So what I'm going to quickly do is just clear all this, and then we'll write out our new h. So what we've got now, if I just do it up here, we've got that h is going to be equal to e to minus a half t times 15 sine 3t. So all I'm doing now is putting my b and my a into the equation. Minus 20 cos 3t. So we've got h. All we need to do now is set h equal to 0, and we can then solve this for t. Okay, so this next bit is quite tricky. There's a couple of different ways you can do it. My way is probably a bit trickier than other ways, but as long as you can get a final solution at the end, then that's absolutely fine, okay? So what I'm going to do now is I'm going to set this equal to 0. So I'm going to run out of room again, but just to make it clear how we're actually doing this. So I'm going to have minus a half e to the minus a half t. And then I'm going to put my a and my b in. So it's 15 sine 3t minus 20 cos 3t plus e to the minus 0.5t 60 sine 3t plus 45 cos 3t. Now this is equal to 0, okay? So that is equal to 0, okay? So let's have a go at this now. So this was my dh by dt. So if I set this equal to 0 now, so we're setting this equal to 0, sorry, not h. So if I set this equal to 0 now we just got to solve and get a value for t. Okay, so like I said, there's a couple of tricky parts here, but again, take your time with it, and we should get there. So the first thing I'm going to do here is take across this minus part here onto the other side. So I'm going to have this here being equal to this, but make it positive, okay? So I'm going to have e, so let me just undo that. So it's going to be e to the minus half t So I'm going to set this equal to this side now, okay? So 0.5 e to the minus half t 15 sine 3t minus 20 cos 3t. Okay, now we need to look at simplifying this. What I'm going to do first, I'm going to times through by 2, because this is a half. So I'm going to times through by 2. So what that's going to give me is that's going to give me 2e minus half t. And then I'm just going to rewrite all this now. Plus 45 cos 3t. So from here to here, I'm just timesing by 2. So I'll just do that here. Times by 2. So that's going to be equal to e to the minus 0.5t 15 sine 3t minus 20 cos 3t. Okay, now we've got e to the minus half t on both sides. Now what I can actually do here is divide through by this e to the minus half t, because e to the minus half t can never be equal to 0, so it will never cause any issues with division. I can actually divide both sides by e to the minus half t. So I'm going to do that now. So my next step, I'm going to divide by e to the minus half t. Okay, so we're going to divide through this. So what that's actually going to leave me with now, and I'm also going to divide in the same step, I'm going to divide by cos 3t, right? Because what I want is here, to get this into a term that I can just put with one single term. Well, if I divide through both sides by cos 3t, I'm going to get this in terms of tan, right? 6, so cos sine over cos will give me tan. So what I'm actually going to get now, all in one line, is 2 lots of 60 sine 3t plus 45 cos 3t, like so, and this is all going to be over cos 3t. Okay, so that's going to be all over cos 3t. This is going to be equal now to 15 sine 3t. Again, timesing through by this e to, dividing through by this e to the minus half t, it'll disappear. So I'm going to get 15 sine 3t minus 20 cos 3t, like so, and again this will be divided by cos 3t. So simplifying this now, what I'm going to get left with is 120. So I'm timesing through by the 2, and then I'm dividing both sides by the cos 3t now, so I'm going to perform that. So I'm going to get 120 tan 3t, and then obviously 45 cos 3t over cos 3t will just give me plus 45. Okay, so I get positive 45. That's going to be equal now to 15 tan 3t, 15 tan 3t minus 20. Simplifying this now, what I'm going to get left with here is 105 tan 3t, so I'll do it over here. I'm going to get 105 tan 3t. That's going to be equal to minus 110. Minus 110. So therefore, tan 3t is going to be equal to minus 110 divided by 105. Okay. So let me just quickly clear this just so we can finish this question. So make sure you've got this down, guys. Tan 3t is equal to minus 110 over 105. So if I write this down, this would simplify to tan 3t. Well, that's going to be equal to minus 22 over 21. Okay. So now we just got to solve this. So solving this now. Well, if I take tan inverse of both sides, so tan inverse of both sides, minus 22 over 21. What that will give me, it'd be minus 0.808. It goes on for quite a bit, 6, 4, 9, and so on. But I'll just write it like that. But we clearly can't have this as our t value, right? T must be positive. So I need the next solution. So to get the next solution, I need to add pi to this. So therefore, this will be 3t will be equal to pi minus 0.80869. Make sure you're in radians here, guys. So this is going to give me, and then what I'm going to do is I'm going to divide through by t. So t is going to be equal to this divided by 3. So divide by 3 here. So what you'll get for t is 0.7782 3 decimal places here. And there we have it. That's our t value for this question. So that's the maximum vertical displacement at the end of the diving board. So that were a lot of marks, and it was quite tricky and very easy to trip up with. And then part C, just for the last 2 marks, asks you to comment on the suitability of the model for large values of t. So kind of a clue there with the large values of t. Well, if you put a large value into your t here, what's going to happen? Well, plug in a large value into t now. Well, we've got this e to the minus a half t, right? So, for example, h equals e to the minus a half t. And then blah, 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 whatever's in this bracket. But we don't even need to worry about this bracket. Think about what's going to happen with this. Well, what I'm going to say as t tends to infinity, what will happen here? Well, if I put a really large value of t in here, this is basically going to be the same as 1 over e, or the square root of e here now. So, if you put a large value in, what you're going to get is that this tends to 0, okay? This will tend to 0. So, what that also means is that h must also tend to 0. So, as t tends to infinity, h tends to 0, okay? So, as t gets very large, h gets smaller and smaller, or in other words, it basically becomes 0. So, what we can say about this now is that this is a suitable model, okay? So, therefore, model is suitable. It is suitable because, like we said here, as t tends to infinity, h tends to 0. It's what we'd expect, right? The board will return to its normal state. So, board returns to a state of equilibrium. So I hope I'm spelling this okay. And there we go, that's it. We just got to say that for your 2 marks. And there we go, that's question 5 fully complete. So I told a little lie. This isn't actually quite finished. I did just miss a little part while doing the recording. And the final part was just actually putting our value back in for t. Okay, so I did all the complicated algebra and then actually forgot to plug this back in. So we got that t is equal to 0.778. So I'll just quickly finish this off. It'll take 2 seconds. We've got to plug this back into h now to actually work out the maximum vertical displacement. So h is equal to, so it's e to the minus 0.5, and then wherever there's a t, just times it by, we're just substituting our 0.778. Times that now, 0.778. And then in brackets, I've got 15 sine 3 times 0.778 minus 20 cos, again 3 times 0.778. Simplifying all this and putting it in your calculator, you'll get 16.7 centimetres. And there we go. Question 5 is now actually fully complete.